blade is a saw that is typically used for cutting through a wide range of materials. The hacksaw is usually lightweight, easy to use, and portable, making it great for construction at home and manufacturing at the workplace. A hacksaw consists of a blade, the arm, and a handle. The blade is carefully crafted and designed through an in-depth material selection process. The hacksaw blade can be made from a number of different materials, depending on its intended use. General-purpose blades are typically made from copper or mild steel. Bimetal blades are used for harder materials, and specialty blades are used for very stiff materials. Once the material is selected, the material undergoes a series of specific treatments to enhance the material's properties and to optimize the performance of the hacksaw. The material first goes through a cold rolling process. Here, the material is rolled into thin strips which are carefully measured and examined. Following cold rolling, 2 holes are punched into the ends of the blade. These holes are used to attach the blade to the handle and support arm for the tool. Once the holes are punched, teeth are cut into the material using a milling process, which is a process using rotary cutters to remove any excess or unwanted material. Hacksaws are generally designed to have forward cutting motion to have more power in each stroke. Therefore, the teeth must be designed and angled to meet this requirement. Thumb screws are also installed later in the process to the ends of the blade to tension the blade so that it does not bend during the push stroke. The hacksaw is then hardened. This optimizes the flexibility and stiffness of the saw. Depending on the intended use for the hacksaw, the blades can be either hardened throughout, which is typically for manufacturing or commercial use blades, or it can be simply just hardened at the teeth, typically for hacksaws intended to be used at home. The blade is then cleaned and sprayed with protective spray to prevent corrosion. The overall geometry of the hacksaw blade is based on its intended use. The length, width, and thickness of the material depend on the diameter of the material being cut, amount of tension and stress acting on the blade, and the environment the blade will be used in. One of the most important features of the hacksaw is the size and the spacing of the teeth on the blade. Specifically, the teeth require an optimum angle in order to maximize the saw's performance. In the blade, the bigger the teeth, the faster the material is cut. In addition to this, blades with a smaller teeth number are intended to be used to cut thicker materials, whereas blades with a greater teeth number are more suitable to cut thinner materials, as seen in the slide above.
Now we move on to how to go about choosing what material to use for the blade. First, let's identify exactly what a hacksaw blade is meant to do. This is the material's function. A hacksaw blade is a cutting tool primarily for metals. In order to cut metals, or any material for that matter, there are a few requirements that need to be met. If you want to cut a material, your blade needs to be harder than that material, or else the blade will just bounce off when you try to cut it. Think of trying to cut a brick wall with a ceramic knife. So the material needs to have a high hardness value. As was mentioned earlier, the blade is attached to the frame in tension with 2 pins at the end. When you start cutting, the load you apply to the beam is counteracted by the tensile force from the pins attached to the frame. So the tensile strength of the blade needs to be high enough such that it won't snap if too much force is applied. At the same time, when you apply this force, it wouldn't work if the blade deforms because then all the force is going into deflecting the blade. Therefore, the blade also needs high stiffness, which is denoted by Young's modulus. Finally, it's important that the teeth don't undergo significant elastic or plastic deformation when cutting for the first time or the 10th. In this regard, the material needs to have a high fatigue strength and a yield strength greater than the stress applied to the teeth by the material being cut. With all these requirements and constraints, what else is needed of a hacksaw blade? Well, like any product, it needs to be competitively priced, but as a hand tool, it's also important that the material is light so that the saw is easy to use. So our material objectives are to minimize price and minimize mass. One thing to keep in mind is that in order to get a good cut, the blade needs to be longer than the material's diameter and thin enough so that the blade actually cuts the material instead of bending it. Standard hacksaw blades have a length of 10 to 12 inches and are approximately 0.63 inches wide. We can assume that the blade will be constrained by these dimensions while the height is a free variable, at least up to the height of the frame. Based on our requirements and the way forces are applied to the blade when cutting, the structure can be simplified to a beam pinned at both ends and subject to a moving point load perpendicular to its length. Now, when comparing our requirements with our objectives, we can derive material performance indices, where the ideal material maximizes the value of the index. We then have the following MPIs: Young's modulus to the power of a third divided by density, yield strength to the power of a half divided by density, and tensile strength to the power of a half divided by density. Our remaining requirements are a bit more difficult to measure using mathematical scales. However, we know that hardness must be greater than the materials being cut. The standard will be one of the most common materials found in households, stainless steel. The same can be said of fatigue strength, since that data for materials is usually determined empirically.
Now, as you can see, the only material to survive our material selection process thus far that is not a steel is cast iron. However, cast iron and steel are very similar. Both of these materials are primarily composed of iron and carbon. The only difference is that cast iron has a carbon content of greater than 2%, meanwhile steel has a carbon content less than 2%. Therefore, since we already know that today hacksaw blades are commonly made from steel, we can say that it's feasible for all four of these materials to be manufactured into hacksaw blades. Now, one factor that are not considered in our derived MPIs is that factor of corrosion. However, all four of the materials found would have a very similar rate of corrosion due to the iron content. Once any of these materials are manufactured into hacksaw blades, there would be a very easy way to slow down this corrosion rate. Some of these ways would be to frequently clean the hacksaw blade, to store in a dry location, and also to every now and then apply oil to the hacksaw blade. Now, the question remains, which of the four materials is the best for the material selection of the hacksaw blade? The objectives chosen were to minimize cost and to minimize weight, so those should be our biggest factors considered when choosing the overall best material. We can eliminate these materials one by one, starting off with the steel. All three of these steels will have very similar properties and are very similar in price and weight. We can first compare high carbon steel to medium carbon steel. Here on this chart, you can see the general and mechanical properties of each. However, one thing that is not considered in these properties or in our derived MPIs is the ease of forming these materials. It is known that generally medium carbon steel is more easily formed than high carbon steel, which is one thing to consider in this decision. However, if we look at this chart, we can see that medium carbon steel has lower values of hardness, tensile strength, and yield strength. So even though it is easier to form, high carbon steel is still a better material to move forward with for the production of hacksaw blades. So we can eliminate medium carbon steel from our decision of the overall best material for the production of hacksaw blades. Next, we can compare high carbon steel to low alloy steel. Both of these two materials have very similar general and mechanical properties, which makes it difficult to determine which material is actually better to be used for hacksaw blades than the other. However, again, one thing that is not considered is the ease of formability. High carbon steel is easier to form than low alloy steel. And since this is easier to form, it'll also be more cost efficient when our hacksaw blade has to be manufactured through this material. Therefore, we can eliminate low alloy steel from our material selection process and move on with high carbon steel, as it will be more cost efficient in the long run. Finally, we can compare our final two materials, high carbon steel and ductile cast iron. The first thing that we should know when comparing these two materials is that ductile cast iron has both a lower weight and a significantly lower price than that of high carbon steel. And these are our two main objectives that we're trying to minimize. However, while these two factors are very important, they can't be the only factors that we look at when making our decision, coming to a final material to choose. If we compare the mechanical properties of these two materials, we can see that high carbon steel has higher values for yield strength, tensile strength, and hardness, all of which are desired in the production of hacksaw blades. Therefore, we can determine that high carbon steel has much more desirable properties in these critical areas, and therefore it is beneficial to use high carbon steel in the production of hacksaw blades compared to that of ductile cast iron, even though it'll be slightly more expensive and add extra weight. One way in which we could change the manufacturing process of the production of hacksaw blades would be to use a typical tempering and quenching process instead of the hammering process which is already used today in the production of hacksaw blades. In this video, you can see a brief introduction to the tempering and quenching process. In brief terms, tempering and quenching is bringing the material up to a certain heat and leaving it there for a certain amount of time, and then quickly cooling this material, usually using water or oil. Using this tempering and quenching process, as well as a high carbon CCT graph, we would be able to get the exact desired hardness value that we want our material to have. An example of a CCT graph of a high carbon steel is shown here. In conclusion, this high carbon steel blade would be best used for most home renovation and general construction purposes. It would be able to cut through most metals that are not high in toughness, as well as most other general materials such as PVC, styrofoams, plastics, and much more. In addition to this efficiency of cutting a broad range of materials, It is also very lightweight, which makes it easy to use and cost efficient, thus fulfilling the objectives required.